All right, let's talk a little bit about graphing rational functions. All right, graphing rational functions. When we graph rational functions, we're going to be introduced to a new little part of this graph that we call asymptotes. Okay? Basically, asymptotes are lines, vertical lines and horizontal lines, that represent places where the graph can't cross. Okay, they represent values of x and y that can't be used in the function. And so if we look at this example right here, y equals 1 over x, well, does it make sense that x cannot be equal to 0? Because if I put a 0 in the denominator of a fraction, that's undefined, isn't it? And so what we're going to find out is there is an asymptote, a vertical asymptote, that goes through 0. We're also going to find out that there is a horizontal asymptote, in this case, that is y equals 0. Okay? And we're going to talk more about that, but then, so the graph of y equals 1 over x looks, well, let's just create some points to double check ourselves. If I put a 1 in for x, I get a 1 for y. If I put a 2 in for x, I get a 1/2. If I put a 3 in, I get a 1/3. So here's 1, 1. Here's 2, 1/2. Here's 3, 1/3. What we find out is the graph looks like this. Okay? And then we're going to find out on this side, if we put negatives in, we're going to come up with this answer. This is called a hyperbola. All right? And it has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And this is the graph of the ordered pairs. Okay? Well, what if we start to mess around and add and subtract more numbers underneath there? Well, what we're going to find out is that this x minus h plus k, the h will represent the vertical asymptote, okay? And the k is going to represent the horizontal asymptote, or it's going to move it, all right, in a certain way. So if we went to and said, okay, y equals 4 over x minus 2, now I know that the horizontal asymptote, we can just set x minus 2 equals 0, and we get x equals 2 then. Now your vertical asymptote is right here. It used to be here at 0, but now it moved over to 2. And then the plus 1 on the end here, the horizontal asymptote used to be here, but now it got moved up to plus 1. And so now our graph is going to look like this. Okay? They get closer and closer to those lines, and they never cross them is what they're there for. All right? So you can determine, so the point where the two asymptotes cross is at 2, 1, right? And those numbers come from there, from the h and the k value. All right? So you can use that to determine where the asymptotes are. Well, what about this now? It's kind of changed form. Well, to find the vertical asymptote, you still just need to take the denominator and set it equal to 0. All right? Because wherever this is 0, that's bad. That whole function, that whole fraction is undefined. So we would say, well, 3x equals 4, and we divide both sides by 3, and we get x equals 4/3. So we have the vertical asymptote is at 4/3, which is also the same thing as 1.75. Okay? And now, in everything we've done before, there was never an x in the numerator, was there? Well, now there is, and so now, wherever the numerator equals 0, that will be our horizontal asymptote. So we'll get 2x equals negative 2, I'm sorry, x equals negative 1, I believe. Yeah, I think we're going to have now a horizontal asymptote at negative 1 right there. And so now we're looking at lines like this. We should probably check it because it could be down here. So we need to check it and just say, okay, what if I put 2 in for x? That's 2 times 2 is 4, plus 2 is 6, over 3 times 2 is 6, minus 4 is 2. I get 3. So 2, 3, yeah. So it's got to be here and here. Okay? There are your graphing simple function ideas.